Well, welcome back, friends, to our discussion of control structures. We're going to return to the second half of our branching discussion today. Branching, if you recall, is the ability of your program to evaluate a logical condition, and then based upon the response of that condition, true or false, to direct the flow of your code one way or another. We began talking in the first video, the part one of this series, about simple branching. That is, we can go one way or the other way, but not a lot of different ways. And that's very useful, and it's probably more common than multi-way branching, but it's limited. We have a choice of two directions. In fact, if we talk about the basic if-else construct, if condition A is true, we will branch in one direction. If condition A is not true, then we will branch in a different direction. Now, we could nest things in order to add some complexity to that program flow. So if A is true, we could nest within there another structure that says if A and this is true, and then if A and this is true. But that gets a little bit complex. So we're going to look at some other constructs today that allow us to expand the capability of our branching. And the first one we want to look at is called the if-else-if structure. Now, when I point to the else-if, when I point out the else-if component, I want you to think of that as a multiple option in your construct. That being, if A is true, we're going to do this. Else if B is true, we will do this. Else if C is true. You can stack up as many else ifs as you like, so long as it makes sense. If you look at your code and you've got 500 else ifs, then maybe you need to rethink your design. But the else if part or clause of this structure gives us the ability to ask a number or evaluate a number of different conditions. Now, here's an example of the else if structure. If we trace this down from the top, if our grade, so our variable grade, is greater than or equal to 90, we're going to output the message test grade equals A. Else if, so rather than just the else clause, which gave us only the second option, we're saying now evaluate yet another logical condition. And so else if grade is greater than or equal to 80, process this, test grade is B. Else if grade is greater than or equal to 70. The nice thing is that the grade, let's say the grade is 75, it is going to drop down until it gets to this clause, because it will not evaluate to be true at grade greater than or equal to 90, grade greater than or equal to 80. It'll only drop through down to here. So you can watch the cascade of your logic as it moves step by step by step. The final else clause that you see at the very bottom of that code, else, is just a plain else clause. So just the same as the if-else structure that you used in the previous video. In this case, if we have evaluated the value of grade and it has, let's say, fallen below 70, so a 69, anything below 69 we're saying is not a passing grade, and we're basically going to pass this the single message back for any numeric grade under the value of 70. So you see that we could have done this with a nested if-else, placing another if-else within there, and then another if-else within that. But the else-if construct makes for some simpler code, so long as it's well documented and it fits your design. Now we're going to go over to the code editor again and look at a live program so that we can trace the execution of the code as we go through. So let's head over to the editor and I'll meet you there. All right, here's our most basic example of the if-else-if code. If grade is 90, then we're going to send the message test is A. Else if grade is greater than or equal to 80, test is. So any condition that falls within these ranges will be captured by the fact that we ask if it's greater than or equal to 90. Now that would allow me to put in a test score of 120, but that doesn't matter for this example right now. If none of the test scores evaluate to true, then it will fall through to our else clause right here. And we will output the message, no passing grade earned. So let's go ahead and we will enter a non-passing grade 65, and we get no passing grade earned. So let's put a breakpoint in here so we can trace how this runs. And we'll execute it again, and we'll give him a grade of 75, so it'll fall down a couple of ways. So you see that it stops on the very first line. It's going to evaluate this logical condition. So is 75 greater than or equal to 90? We know that to be not true. Is it greater than or equal to 80? We know that not to be true. Now it is greater than or equal to 70, and so it will drop in, give that message. The else clause is not executed. We go and we get the grade of C. So the if-else-if, very simple. You can stack up as many as you need, just so long as you catch all of the conditions. You also want to think about the order in which you look for items. It would not make sense to look for example, greater than or equal to 70 first, because every grade, the 90s, the 80s, and so you want to be very cautious about how you construct your evaluation expression. So I'm saying greater than or equal to 90, so that gets me everything above. But if I wanted to do it backwards, I would say less than or equal to, less than or equal to, and so on. So you want to be really cautious about how you design the sequence of tests and the way that you construct the expressions that you're going to use. So let's go back and have a look at some new operators that allow us to build compound statements. All right, the if-else-if gives us a lot of options, but there are some additional operators that we can build into our code to expand the logical evaluation process just a bit further. The AND operator and the OR operator allow us to evaluate multiple conditions. That is, we can create compound statements that ask questions if condition A is true and condition B is true, or if condition A is true or condition B is true. And then based upon that compound logic, again, we can control the flow of our code. Let's have a look at the AND operator. The AND operator is composed of two ampersands side by side. Some compilers support the substitution of the word and, A-N-D, in all uppercase for that operator, but standard C++ terminology is ampersand, ampersand. You need to check with your publisher to see what's supported. Anyway, the AND operator evaluates a statement, and both sides of that statement, that is, both logical conditions, must evaluate to true in order for the entire statement. That is, everything within the surrounding parentheses must evaluate to true in order for the whole statement to be true. So if condition A is true and condition B is true, then the entire statement evaluates to true. On the other hand, if one of the two conditions is not true, then the entire statement becomes false. So if condition A is true and condition B is false, well, then the entire statement becomes false. The AND operator requires true on both sides of that. The OR operator, composed of two bars, that is the symbol that you see above your backslash key. The OR operator works just the opposite. If either side of a compound expression is true, then the entire statement becomes true. So we have a true statement in condition A and a true statement in condition B. Well, that logically will evaluate out to true because both of them happen to be true. In the second example here, where we see condition A equals false and condition B equals true, well, condition B makes the entire statement true. Only when both conditions evaluate to false does the entire statement become false. So if condition A is false or condition B is false, then the entire statement evaluates to true. So again, let's have a look at our code editor and look at some live code to see how this plays out for us. We have modified our grading program to utilize the logical operators. In this case, I'm going to use all ands here. And what this allows me to do is to add some additional gradation to my program flow. That is, I can test for finer conditions. So if you look at the first line up here, so now you notice that we've changed it to grade is greater than or equal to 93. So we're going to go back to a plus minus grade scale. And instead of just A, B, and C, we'll have A minus, B plus, B minus, and so on. And the way we do that is by evaluating where their grade falls within a much finer range. So greater than or equal to 93, very simple. Here's our first compound statement. Greater than or equal to 90, and the grade must be less than 93. So both of those conditions must be true, and in that case, the student will receive an A minus. Dropping down one more, the grade is greater than or equal to 88, and the grade is less than 90. So 88, 89 gets you a B plus, and so on down the list. Nothing has changed at the bottom. You still fall below a 70, and you have not earned a passing grade. So let's execute this just to prove our theory. We'll give the user an 82. I think we would expect a B minus on this grade scale, and in fact that's what the user gets. So just to review real quick, the addition of the logical operator, the AND there, says that grade must be greater than or equal to 73 and at the same time less than 78 in order for the student to earn a C. So both sides of that have to evaluate to true. Now I'm going to substitute in some different code because I want to show you something a little bit more complex here. So let me just copy this over, add this into our source file. And what I've done is add a little error checking. So I'm going to combine what we learned in the first video, that is the nesting of if structures, and I'm going to nest our if-else-if structure within a simple if-else structure. And what that does is it allows me to parse out bad grades that might be input. So my first evaluation using an OR operator is if the user gives me a grade that is less than 0, so if I accidentally enter minus 10, or the user gives me a grade that is greater than 100. So if either of those conditions is true, I consider that to be an invalid test grade, and I will report that back to the user. If one of those conditions is false, then it will drop through and allow me to, if both of those conditions are false, then it will allow me to drop into my simple else clause, and there I have nested the if else if structure that we had before. So let's execute this. Jeopardy music, there we go. Okay, so let's give it a minus 10 just for grins. Invalid test grade, we'll execute again, and 110 invalid test grade, and then we know how it works after that. So we'll give it an 88, user gets a B plus, life is good, students are happy. All right, so you see how we can combine control structures. And this just doesn't apply to the branching structures. This is anything. We can nest one control structure inside of another ad infinitum in order to create the program flow that matches our design. And a lot of programming is going to be like this. You're going to be nesting one decision inside of another decision inside of another decision, or we will nest one repetition structure inside of another to loop inside of a loop inside of a loop, and so on, in order to meet the requirements of our program design. Now let's go back and have a look at one more new control structure, one more new branching structure called the switch. The last branching statement is maybe the simplest of all of them, and that is the switch statement. The switch statement is unique in that it works only with integrals. Remember, your integrals are your integers, your characters, your booleans, and your enums. Those are the only things that are integral data types in C++. The switch statement works in two parts. In the switch, the proper switch itself, you will follow up with an expression, so a variable. That variable is then compared against any number of cases. So each case will represent a single integral. So we'll see in the example, in fact, we'll just go to the example now, it makes more sense. So we have a variable called grade. Grade is a character variable, and we're going to compare grade against these three cases. If there were more grades, we would have more cases. But in this case, we have a single character, A, B, C. So if grade equals A, then the code that is enclosed in that case will be processed. B, processed. C, processed, and so on. This is a fantastic little structure. It's especially useful for menuing type options, where the user is going to provide you with a menu choice, and then you process different logical flows based upon the menu choice that the user gives you. The only thing that holds this back is you can't use compound statements. You can't use anything other than integrals to evaluate it. So there's no gray area within this structure. But again, let's go to the code and have a look at how it plays out in real life. And I think once we look at the code, you'll see the application for this structure. All right, now we have the code changed to utilize our switch statement. And you see the switch statement is evaluating the variable grade. So what it's going to say is, does case A match the grade? Does case B match the grade? In this case, I'm using character integrals. You could use integers in here or enums, whatever fits your program best. Now, when this executes, this will go through, evaluate the grade that I provide against what it sees in the cases, and then process the output statement. So let's give it a quick whirl. We'll give them a C on their midterm, and they get the message, it's a good chance to improve your grade by doing well on the final. Now there's a couple things that I want to point out here. In using the switch statement, the number one mistake that programmers make in typing the switch statement out is they forget to add the break clause. Nowhere else in C++ should you be using the break keyword on a regular basis, but here it is essential. What the break statement says is, once I reach this statement, ignore everything that follows in the remainder of the logical structure. So once it hits this break statement, it's not going to test any more cases. It's going to go from here out to the next logical statement once it gets out of the construct or the control structure construct. If you forget to put the break statements in, well, I'll just show you what will happen here. Let's comment out the break. So that is the same as forgetting to put it in. What will happen is that this will process every logical statement until it hits a break statement. So if you forget to do it on all your statements, you'll see what will happen. So I'm going to give the user an A in their midterm, and you see that I get both messages. You don't need to take the final, and you should do just fine on the final. So that is the A and B message. So you need to make sure that you put the break statement in there. Another thing that I didn't show you before is you can use that capability or flaw, depending on the way you want to look at it, is to combine multiple cases together into a single action. So you see right here, I have the D and then the F stacked up on top of each other. So I'm going to allow a D grade or an F grade to fall through and process. That's because neither one of those is a passing grade. And so if the user gets either a D or an F, it's going to drop through and process the not good, go steady message. And we'll just test that right quick. That is because of the absence of a break in there. So if I give it a D, you see it drops through and tells the user to go steady. All right, the last thing that I want to show you on the switch statement is the default statement. What the default statement does is if every other condition has evaluated to false, that means none of these conditions have matched grade, default allows me to do some process based upon that fact. In this case, I'm going to use this to provide an error message to the user. They have given me an invalid grade. So as I execute, let's give it a grade of X. And you see that that didn't match any of the cases. And so it falls through and gives me an invalid grade. So that will drop through and process this message right here. So now you have the complete toolbox of branching structures. If else, if, the compound operators that allow you to create compound evaluation expressions, and finally the switch structures. Using one or many of those, you can nest all of these together, will allow you to create some very complex program flows. You just want to remember that everything that you do should match your design. You want to make sure that the structure that you select doesn't force your code into any particular flow. It fits with your design. Thanks for being here again. I hope you enjoyed the video, and good luck on your programming. I'll see you next time.